Hello everyone, welcome to experimental biochemistry course. In today we are going to study the enzyme kinetics. Actually, when substrate attaches to an enzyme, it is degraded to form products. So basically enzyme acts on a substrate and substrate attaches to the active site of the enzyme. It is chemically acted upon by the enzyme, the substrate is actually chemically acted upon by the enzyme and it is degraded to form a completely different chemically product. Okay. So, in today's study we are going to see how this phenomenon takes place in terms of spectrophotometric analysis. Before going into our experiment, I just want to give you a small example which we generally see in everyday life. I hope all of you are acquainted with apple. Okay. So, when you cut apple into small pieces and keep it open in dry air, actually what you see is that the yellowish part of the apple, which is the inner part of the apple, gradually gets converted into brown color, and with gradual progress in time the color gets darkened and deep brown color is formed in the apple. So, why this phenomenon takes place? The general concept lies in the fact that there are various types of phenolic compounds like catechol or other polyphenolic compounds present in the apple, which are actually oxidized in presence of air. And who oxidizes it? Generally molecular oxygen cannot carry out this oxidation until and unless an enzymes comes into play. The enzymes which comes into play is actually catechol oxidase, which is generally present in an apple. So, this is an apple. So, when we will cut it into pieces, we can see that the color turns brownish with gradual exposure in air. So, this catechol oxidase present in an apple is basically converting the substrate, that is catechol, into oxidized product, which is actually benzoquinone. Now, the phenomenon which we see in regular life, we want to quantify it and see how the kinetics occur, that is how fast or slow the reaction takes place. For that, what we need? We need the enzyme. We need the enzyme from this apple. So, we will see how we can carry out the extraction of that enzyme, or basically the solution from this apple. And number 2 is that we need the substrate, and what is the substrate? It is catechol. So, we will actually prepare a solution of catechol and we will add this enzyme obtained from apple to it and see how the kinetics or how the reaction gradually takes place using UV spectrophotometric techniques. In addition, what we can do is that we can add one inhibitor. You have seen in your theory classes that an inhibitor actually slows down or actually modifies the rate of the reaction, or in certain cases actually stops the enzymatic reaction. So, in our case we will apply any one of the enzyme, or basically 2 enzymes, actually it is phenylthiourea number 1 and the other is para-hydroxybenzoic acid. So, we can see how this chemical compounds acts on this enzyme and prevent the enzyme reaction. So, let us proceed into our experimental procedures. So, the substrate we are going to take is catechol. Here this is catechol, this is the 100 gram catechol in a bottle. So, we are going to prepare 20 millimolar of 50 ml catechol in phosphate buffer pH 7.4 solution. So, keep in mind that all the solutions we are carrying out in this reaction, all the solution are preparing in this reaction, we are doing it in phosphate buffer pH 7.4, and the strength of the phosphate buffer you can actually vary from 10 millimolar to 20 millimolar or 25 millimolar. Generally all the biological processes are done with this concentration of phosphate buffer. Now, we are going to take this spatula and we are keeping in mind that the spatula should be clean. Actually, we are cleaning this with a tissue paper and visually it is clean. However, we are again cleaning this with a tissue paper. And now, we are going to take this catechol. Now, we have calculated it for 20 millimolar and 50 ml catechol solution, we require 0.11 gram catechol. So, we are taking 0.11 gram catechol. Here is the butter paper. We have teared this and it is 0 is showing. Okay. Initially, we are adding a small amount of this catechol powder. These are catechol are generally crystals. Okay, so we have taken actually 0.1138 and gram of catechol. So as we have said in the previous lectures that whatever is the calculated amount, the calculated weight, you can take a small amount a bit higher than this calculated weight. Okay. Now we have taken this clean falcon, this is a 50 ml falcon tube. So we have dried it and properly cleaned it with double distilled water. So we will transfer this catechol crystals carefully into this falcon. Now after that what we will do, we will actually take this falcon and make up this volume up to 50 ml using phosphate buffer of pH 7.4 and strength either 20 or 10 millimolar. Basically here the phosphate buffer we have prepared out here is 20 millimolar. So what we can do is that we can take half of this phosphate buffer and fill here up to 25 ml and then make up the rest of the volume with double distilled water, so that the final concentration of phosphate buffer is 10 millimolar. You can actually keep 20 or 25 as per your wish. However, sometimes this concentration might affect the reaction, so we can try out this reaction with 10 millimolar of phosphate buffer initially. Now since this is a falcon tube and the mouth is quite large, so we can actually add this one, transfer this one carefully. Once we have poured a small amount of this phosphate buffer, you can stir it gently. For beginners, you can use actually a pipette or like a 10 ml pipette, which we have seen in the previous experimental classes. And here is the graduation we can see. We will pour up to 25 ml. Here I have added 25 ml of phosphate buffer, and now what we can do, we will actually stir this solution. So that this catechol dissolves in the phosphate buffer. Now we can see here there is no such crystals floating in this solution, so it is completely dissolved. Now to this one we will be adding double distilled water. So the volume is actually, here we can see it is 50 ml. Okay. Again, what I am suggesting for beginners, you can actually use pipette while pouring this double distilled water or buffer into this one. So here what we have made actually 20 millimolar of catechol solution. Now one thing is that you could easily have added double distilled water, phosphate buffer, and after that this catechol powder out here, and what actually problem takes place in that case is that the volume correction may not be present in case where you have added the solid catechol after adding double distilled water. So always put the solid crystals, so whatever you have taken the solute, you usually take it in this falcon tube and then add the required solvent. Now we are going to prepare around 10 millimolar and 50 ml of the inhibitor. The inhibitor we are taking here is N-phenyl thiourea. Okay. So this is often referred to as PTU. You can see. So this is actually a 25 gram bottle having solid N-phenyl thiourea. Okay. And the molecular weight is also mentioned with the molecular formula. So we are going to prepare around 10 millimolar and 50 ml phenyl thiourea in the same procedure as previously we have done for catechol. Now, we are going to prepare 10 millimolar of 50 ml phenylthiourea. For that we need 0.076 gram of PTU, that is phenylthiourea. We have again taken this spatula. The spatula we have used previously, we have cleaned it properly with double distilled water, and then after that with a clean tissue paper we have dried it, and then again we are using it to take this phenylthiourea. We have again taken a clean butter paper out here. Please do not reuse the butter paper which we have taken for weighing a previous solute. So, we have tiered it, it is 0.00 gram. Now, we are going to take a pinch of this phenylthiourea. Now, this is 0.02 gram, we have to add a bit more. It is 0.03, 0.06. And now it again increased to 0.09. So, what we have to do? We have to take a small pinch of this phenylthiourea out here and transfer it into another butter paper. So, what you can do is that you can actually take this excess of solid compound, if it is transferred to the butter paper, into the same container, or otherwise you can actually omit it. Generally, in this case we are not transferring it in this one because some contamination might be there. We are trying to avoid this because this should be pure, the actual container. Now, is 0.80. Okay, 0.078 it is. Before transferring it, we are again closing this container properly. And now again we have taken a new falcon, washed it properly with double distilled water, and if preferable you can actually rinse this one with phosphate buffer. The phosphate buffer you would be using for making this entire solution. So, I have rinsed it previously with phosphate buffer. As you can see, the water droplet actual droplets are still here out. Now, we will take this one phenylthiourea and transfer it carefully. So, here we have taken the solid phenylthiourea, as you can see here the solid compound is there. Now, again we will be adding phosphate buffer 25 ml of 20 millimolar, that is page 7.4. Now, we have to stir it. Here what we can see that the compound is not properly dissolving out here. So, for that we need to add again double distilled water. So, we have to change the concentration and increase the volume. So, although we can see that it is not dissolving properly, but if we actually give it for sonication out here, it will get dissolved after sonicating it for some time. Now, we will give it for sonication. In the meantime, we will prepare another solution, that is para-hydroxybenzoic acid. The next inhibitor we can prepare is para-hydroxybenzoic acid, as here we can see in this bottle. So, we can use either of the two inhibitors, either PTU, that is phenylthiourea, or para-hydroxybenzoic acid. Now, we are going to prepare this one. We are again going to prepare 10 millimolar of 50 ml of para-hydroxybenzoic acid. For that, we need 0.069 gram. Now, we have again taken this cleaned spatula and a fresh butter paper out here, and after tearing, we are adding a small pinch of para-hydroxybenzoic acid. Our aim is to get 0.069 or basically 0.7 or 0.07 actually. It is 0.03, and if we add a bit more, it is 0.053. It is 0.0649 now. It's 0.0649 and a small pinch out here. Again it has increased to 0.08. Now we will again take another butter paper and we will transfer a bit from here. It is 0.074. We can take a small amount. Now it is 0.0703. We will again close this container, and we have taken again a falcon, clean falcon. This is the falcon in which we will transfer this solid, that is para-hydroxybenzoic acid. We will carefully transfer this one. So, here we can see the para-hydroxybenzoic acid is out here, and again we will be adding 25 ml phosphate buffer. Here is the graduation. We will put this lid and we will stir it. Here we can see it is almost dissolved in the solution. A few particles are there which are actually floating in this falcon tube. So, now if we make up this volume with double distilled water, we can actually see the complete solute dissolves out here. So, I have made up to 50 ml, and now it has almost dissolved, or rather completely dissolved in phosphate buffer. Now, we have prepared all the three types of solution. Number 1 is catechol, number 2 is PTU, and we have sonicated it a bit, and here we can see that the color, it is almost soluble now. We do not see any such solid particles floating out here in this PTU solution. And the third thing we have prepared is para-hydroxybenzoic acid. Now, the main thing we require is the apple enzyme. So, we will now prepare the apple extract by taking this fresh apple. So, from market you have to just get a fresh apple, and let us see how to get the apple extract from here. Now, we are going to extract the apple juice, or rather the apple extract from this apple. For that we need few things. Number 1, is the fresh apple just bought from the market. Number 2, a knife, okay, clean knife, be careful while using a knife. And then number 3, a mortar pestle out here, and number 4, a beaker where we will transfer this apple extract, and number 5, a cloth. Okay. So, instead of this mortar pestle, you can also use a mixer grinder, a juice mixer grinder, that would be much more easy. Okay. So, let us proceed for this experiment. So, we have taken this knife, we have cleaned it, and now we are going to cut this apple carefully. Now, we have taken out this fresh piece of apple. As you can see, this one is yellowish color, but when you keep it in air for some time, this color turns into brownish. Now, we are going to make the small pieces out here, and the small pieces we are going to put it in the mortar pestle. Try to make small pieces so that it will be better for grinding. Now, we are again taking the previously cut pieces and making smaller fragments out here. Be careful while cutting this one. Here we can see it has already started turning into slightly brownish. আচ্ছা এটা না বাদ দিয়ে দেবো ওখান থেকে। Now, here we can already see that a part of this apple, the inner part, has already started turning a bit brown. Okay. So, this is a regular experience we can see, but many of us might not know the reason. The actual reason is that the phenolic compounds are getting oxidized by the catechol oxidase enzyme, and the enzyme is actually present in the apple. Now, what we can do is that we can basically mix this one. Here we can see we have taken a bit large amount of apple out here, pieces apple. We will first grind this one using a pestle and then we will add the remaining pieces. Okay. So, the pestle what we have taken here, we will actually grind this one. It is better to grind with smaller pieces of apple. And while you have started grinding, add small amount of water. Now, once we have made a small amount of this apple extract as we have seen in the video, now we can add the remaining pieces. One thing which I basically experienced while doing this one, and I would like to recommend you also, basically peel off the skin at first, the apple skin. You can basically peel this one off, remove this part having the skin of this apple, and then make small pieces. And you can add those into the mortar. Again, out here I will be removing the skin. Okay, now I have removed the skin of this piece of apple out here. I have removed as much as possible. Okay, this one is there, and again I will be making smaller pieces. Now I will again add double distilled water and grind it in the previous way. Now, what we have got actually is something like this. Out here we can see the apple pieces, and the liquid is actually the apple extract with the present in water. Now, we have to take out this extract using this cloth. So, let us see how to take out this apple extract from here. Now, we have taken this beaker, okay, where we will take in the apple extract, and a cloth and a piece of cloth out here. So, we are keeping this piece of cloth on this beaker out here, and in such a way that a part of this cloth goes inside. Okay. Make it sure that you are placing the sample in the mid of this cloth. Now, out here we can see here is the apple extract. We will again add some amount of water, and we will transfer this in this cloth. Along with the entire thing, we will transfer out here. Now, after that we will fold this one, and here already we can see a small amount of this liquid is present there in the beaker, and we will actually press here such that the apple juice comes out. In this way we have to take the apple extract. Again we can add small amount of water. And press it such that we get the apple juice from here. In this method what basically happens is that the remaining the solid apple pieces are actually filtered out here, and we can get the filtrate, that is the apple juice. Out here we can see here this is actually almost clear solution. It's almost clear solution of the filtrate, and here in this cloth we have the solid apple residues which we will not use, and we will discard this one. And with this filtrate we will proceed to our analysis, and we will dilute this filtrate a bit because this is highly concentrated. We will dilute a bit, and with this we will proceed to our enzyme kinetics analysis.